Hello ladies and gentlemen, this is Salman Sheikh from Best Cloud Prep, and in today's lecture we will quickly look at the DNS service in AWS, that is Route 53. So Amazon Route 53 is a highly available and scalable cloud domain name web service, which is basically your DNS web service. It is designed to give developers and businesses an extremely reliable and cost-effective way to route end-user traffic to internet applications by translating names like www.example.com into the numeric IP addresses like 192.0.x.1. So let's start my Route 53 exam tips. This is mainly for the Solutions Architect Associate exam. So now always remember that the elastic load balancers or ELBs do not have predefined IPv4 addresses. So you resort to them using a DNS name. You should definitely understand the difference between an alias record and a CNAME. So basically, the CNAME record maps a name to another name. It should only be used when there are no other records on that name. Whereas the alias record maps a name to another name again, but can coexist with other records on that name. So also remember that the URL record redirects the name to the target name using the HTTP 301 status code. And then given the choice between an alias record and a CNAME in an exam scenario, I would always choose alias. For example, if they are asking things like you need to map your naked domain name or your zone apex record to an S3 bucket, for instance, what should you be using? And a CNAME or an alias record? Well, the answer will be alias record. So that is one exam scenario tip. So some common DNS types include start of authority records. So SOA, start of authority records. NS records, A records, CNAMEs, MX records, and PTR records. And the following routing policies are available with Route 53. So we've got simple routing, then we have weighted routing, latency-based routing, failover routing, geolocation routing, geoproximity routing, and multi-value answer routing. So you should also learn about health checks. You can set health checks on individual record sets. If a record set fails a health check, it will be removed from Route 53 until it passes the health check. So you can set SNS notifications to alert you if a health check is failed. So let's talk about different routing policies. So first we have simple routing. So if you choose simple routing policy, you can only have one record with multiple IP addresses, and you can't have any health checks. So remember this. So if you specify multiple values in a record, Route 53 returns all values to the user in a random order. So as you can see in the diagram, here's our user typing in a DNS address. Route 53 is giving them the first record, and then it's giving them the second record. But we can't have a health check on that one. This is simple routing. Next is weighted routing policy. So here's our user typing in a DNS address, and we are setting weights. So we are sending 20% of the traffic to US East 1 and 80% of the traffic to US West 1. So that's how weighted routing works. Now we have latency-based routing. It is basically based on our user's location and the latency. So as you can see in the diagram, our South African user are going to visit our website. It's behind Route 53, and essentially they are going to get 54 milliseconds if they are going to use EU West 2, and 300 milliseconds if they are using AP Southeast 2. So obviously Route 53 is going to send them to the fastest fleet of TCP instances, in this case EU West. Then comes failover routing. It is where we start using our health checks. So essentially, we've got an active passive environment. So our active environment could be EU West 2, and our passive environment could be AP Southeast 2. If for some reason, our EC2 instances or a region goes down, it's going to detect this using health checks, and it's going to fail over to our passive environment. Now comes the geolocation routing. It allows our European customers to be sent to our European servers, and it allows our US customers to be sent to our US servers. It doesn't have anything to do about latency. It actually physically knows where our customers are and then makes routing decisions based on that. So that's how geolocation works. Now we have geo-proximity routing. It allows you to create route traffic to your resources based on the geographical location of the user and your resources. So previously, geolocation was used to physically. This also knew that where our user was located, and it just used to direct the traffic, knowing where our user was. In here, geo-proximity, it knows both the geographical location of your user and also your resources. So remember this difference. And to use geo-proximity routing, you must use Route53 traffic flow. And then finally, we have our multi-value answer policies, and essentially this is the same as with the simple bit-based routing, except you get health checks. So you can have multiple values in your record set. So we have got our record set in here. We have got our first and second, as you can see in the diagram. And if one fails a health check, what's going to happen is that it will be removed from the record set, or it's going to stop serving that record until it passes the health check. So that is it, guys, from this section of the course. I hope it gives you an overview and summary of the DNS service in cloud, that is AWS Route53. In the end, I would like to acknowledge and thank Kroneberg Brothers from a cloud guru platform. If you have the funds and time, please visit their website and learn from the best in cloud computing. If you find this video helpful, please like, share, and comment. Thank you, and hope to see you in the next lecture.